Today we will be discussing finding the volume by integration using the disk or washer method. But before we do that, I would like to explain the difference between a two-dimensional plane and a three-dimensional space. So all of my previous videos were about two-dimensional plane, wherein we have two axes. So we have an x and a y axis, and to get the area, we have a measurement area of 1 square unit, where we have a square and the side will be 1 and all the sides will be 1 unit. So for example, we have a rectangle that has a height of 3 units and a length of 4 units. To find the area, we need to find how many square units can fit inside that rectangle. So if we put lines, we make this into squares, we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this rectangle has 12 square units. So 12 square units, or 12 units squared. So that's how we find the area. In a three-dimensional space, there's a third axis. So for example, this is your x, this is your y. There will be a third axis on this moving on this direction. There will be a third axis, and it's called the z-axis. Now if we draw it, if we move it slightly forward on the right, it will look like this. This is still your x-axis, this is your y-axis, and this is your z-axis. If we extend the axis beyond the positive and continue with the negative, it will look like this. So this is your x-axis, this is your y, and this is your z. So this is this from this side is positive, this side is negative. The y-axis, this is positive, this is negative. For the z-axis, forward is positive and backwards is negative. Now the unit of measurement for the volume is the cube, cubic unit, 1 cubic unit. A cube with a dimension of 1 unit on all the sides. So for example, we have a rectangular solid, and we want to measure the volume of this solid. We just have to see how many cubes of 1 unit on each side can fit in this one. So let's say we put the line on all the we put the one, divide it into 1 unit of cubes. So that would be like that, and this will be like this. Yeah, sorry for the drawing. Now 1 cube would be exactly 1 unit cube. So if we count the number of cubes, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the top portion is 12, but there are 2 layers, so that will be 24. Or in short, we just multiply 2 times 3 times 4 is 24. So there will be 24 cubes in this rectangular solid. So that will be 24 unit. So you can put unit cube, or sorry, this is 24 cubic units. So that would be your volume. Now we go to the integration. In my previous videos, we find the area for the, like for example, this is the area that we want to find from 0 to c. So to get the area, we get the integral of this height. This is more like a rectangle, a very thin rectangle, and we get the height by using the the function, which is the function of x, which is this one. This is the height multiplied by the thickness of the rectangle. So we get the area. So we get to integrate from, for example, from here we get the integral from 0 to c of fx multiplied by dx. So that will be your area. Now, moving forward to a three-dimensional space, try to imagine. So now, if we have this two-dimensional plane, and we will add a third axis here, the y-axis, it will look like this. So this is still your x. This x is this x-axis. Your y is this your y-axis, and this is your z-axis. And now the curve will look like this. So try to imagine this one is moved slightly forward from the right. So it will look like this. If we rotate the whole curve 360 degrees around, so it will look like this. So the curve would look like a bullet. It will look like a solid bullet, or in side view it will look like this, or slightly side view. Now we can get the volume by slicing this shape into small discs. So this dx, you have to, if you rotate this dx, it will look like a small disc. So the small disc, what would it look like? It's like this. This is an example of a disc. So a disc is like a cylinder with a very thin height. Now, so we can get the volume of this disc, and then we integrate from the start to the end to get the volume of the whole thing. Now, this let's from basing on this disc. So if you have a disc, this is your disc. Okay. Now your disc will have of course, it will have a radius, and it will have a thickness. This is your thickness. That will be your dx. So the thickness, this one will be dx, the thickness of the disc, and then it was rotated. So we get the area. The area for this one is, the volume for this one is the area times the area of the circle times dx, the thickness. So the area of this one times the thickness. That will be the volume of this disc. But the area of the circle is pi r squared. So the volume of the disc would be pi r squared times dx. So this will be the volume of the disc. Now, if we want to get the volume of the whole thing, we need to get the integral from the start to the finish of this volume. So the volume would now be, so the integral of pi r squared dx. Now since the pi r squared dx, but since the pi is a constant, we can take it out. So the volume would be pi multiplied by the integral of r squared times dx. So from start to finish, so from, in this example will be from 0 to c. So this is your volume. Example number 1, the question is to find the volume of this curve from x is equal to 1 to x is equal to 3 and made to rotate around the x-axis. So let's try to draw this one. It made to rotate this on this one, and this one is, it will look like, the curve would look like this. It's like a flower pot leaning on the side. Now, to get the volume of this one, we first need to make a thin rectangle from the curve, and that would be dx. So that rectangle, if you are made to rotate it, it will look like this. So that it would look like a disc, similar to this. It will be like a disc where the thickness will be dx, and the area of that circle will be pi r squared. So let's try to draw the disc. So I'll also isolate this disc. So this will be your disc. This is the x-axis. So the thickness of that one is dx. Now the area will be, this will be the radius. The radius will be the function of y. Function of y. Now to get the area of this circle, this is pi r squared, where r is equal to y. So this is the area. Area is pi y squared. Now this area multiplied to the thickness will give you the volume. So the volume would be of this disc is pi y squared times dx. So this will be your volume of the disc. Now because what we needed is from 1 to 3, we need to integrate. We need to integrate from 1 to 3. So the volume would be the integral of pi y squared dx evaluated from 1 to 3. So it's a combination of all the small discs from 1 to 3. So this will be your volume. Now because this is constant, the pi, we can take it outside. Pi integral from 1 to 3 of y squared dx. Now in this case, y squared is equal to this. This is your y squared. This is your y. You have to square this one. So your volume now becomes pi times the integral from 1 to 3 of y squared. Your y is x squared plus 1, x squared plus 1, and then you have to square it times dx. So that will be your volume. Now, so since this is squared, you have to square this whole thing. Maybe I just write in this side. Volume will be equal to pi. If you square this one, it will become x to the 4th plus 2x squared plus 1 evaluated from 1 to 3 multiplied by dx. So I will square this binomial and became a trinomial. Now to integrate, So following our rules of integration, now this will become like this now. So if you integrate this one, it becomes x to the 5th over 5 plus 2x cubed over 3 plus x evaluated from 1 to 3. So volume is equal to pi. I'll get a new bracket. So we use 3 first to substitute all the x in this one. So this becomes 3 to the 5th over 5 plus 2 times 3 cubed over 3 plus 3. So now we've replaced all the x in here with 3, and then minus, this time we replace all the x with 1. So that will become x, this becomes 1 now. One to the 5th over 5 plus 2 times 1 cubed over 3 plus 1. Now, all the x in here is now replaced by 1. So the integration part is the easy part in here. The hard part is actually dealing with exponents and fractions. So let me proceed. Pi, and then 3 to the 5th is 243 over 5 plus, this becomes 18 plus 3. Minus, so this becomes 1 over 5 plus so 1 cube is 1, so this becomes 2/3 plus 1, and then so now to add this one, it's easier to put a denominator of 1. So volume is pi times, so the common LCD of 5, 1, and 1 is 5. So I mean, this is from my previous video on how to deal with fractions. So LCD is 5. 5 divided by 5 is 1 times 243 is still 200. 5 divided by 5 is 1 times 243 is 243. Now 5 divided by 1 is 5 times 18 is 90. Plus 5 divided by 1 is 5 times 3 is 15. So this is minus. Now the LCD of 5 and 3, let's put 1 in here. 5, 3, and 1 is 15. 15 divided by 5, 3 times 1 is 3. 15 divided by 3 is 5 times 2 is 10. 15 divided by 1 is 15 times 1 is still 15. Okay, so the volume is pi 243 plus 90 plus 15 is 348 over 5 minus 3 plus 10 plus 15 is 28 over 15. So LCD, now we can subtract this one minus this one. The LCD of 5 and 15 is 15. So volume is pi times LCD is 15. 15 divided by 5 is 3 times 348 is 1044. 15 divided by 15 is 1 times 28 is still 28. So the volume is pi times 1016 over 15 cubic units. So this is your volume. Example 2, the question is to find the volume generated by revolving these two curves. This upper curve is y is equal to square root of x, and the lower curve is y is equal to x squared over 8. The question is, if these two curves are made to revolve around the x-axis, so it would look similar to this. And of course in here it will be like a mirror image, not equal but so very close to equal. So this one is made to revolve around the x-axis. Now the way to the washer method is to get this a rectangle from here. So this will be the x. Now if that is made to revolve in this method, it will be it will look like this. So it will look still, it will still look like a disc, but with a hole in the middle, and that is the shape of a washer. A washer is like this. Is a washer. It's used in carpentry and nuts and bolts. So this would look like a washer. So this washer, we can integrate it from the beginning to the end. So we can get the small, the thin washers, integrating the thin washers, and we can get the volume. Now the easier way to do that is to first get the volume of the upper. So this is your upper curve. So we get the volume of that one, and then when we get the volume of this one, that one we can subtract it from the volume of the other one. So what we will have left will be this volume minus this volume. You will have this volume. Yeah, so this will be, you rotate this, you'll have it will be in the shape of a cup. This will be in the shape of like a funnel. If you subtract this one from this one, you will have this shape, a funnel shape. Funnel in the inside, but it looks like a cup on the outside. So to do that, so we first need to get the point of intersection. I'll rewrite this one, it's a bit easy now. So this is your first curve, this is your second curve, This is y is equal to square root of x. This is y square root of x squared over 8. So to get the point of intersection of these two curves, so you equate these two equations. So this is x squared over 8 will be equal to square root of x. Again, the point of intersection is in another of my video, and you can look at that to have a review on finding the point of intersection. So now that we have this equation, we equated y is this one and then y is this one. If we equate that one, you can find the point of intersection. So equating this one, so we multiply 8 on both sides, it will become x squared is equal to 8 square root of x. So to remove the square root, we square both sides, it will become x to the 4th is equal to 64x. Now we can divide x on both sides. We can factor out x. So what you have is, if you put all the variables on one side, it will look like this. 8 squared is 64. Sorry, 8 times 8 is 6. So you squared it first. X squared becomes x to the 4th. 8 squared is 64. Square root of x squared is x. So putting all the variables on one side, we have x to the 4th minus 64x is equal to 0. So you want to equate it to 0, so to find the point of intersection, I'll just rewrite it here. X to the 4th minus 64x is equal to 0. So we can take the common factor x. So this becomes x cubed minus 64 is equal to 0. So this one we equate to 0, it becomes x is equal to 0. If we equate x cubed minus 64 equal to 0, so adding 64 on both sides, we have x cubed is equal to 64. Getting the cube root of both sides, x is equal to 4. So these are your two values, x is equal to 4 and x is equal to 0. So the point of intersection is this one, x is equal to 0, and then this is x is equal to 4. So this from here to here is 4. This is 4. The length. Now we first we get the volume of this one. So the volume of that one would be area is equal to pi r squared dx, where r is equal to the square root of x. So, but we need to integrate it, so the volume would be, we can separate the pi again, integral from 0 to 4 of, so r is equal to square root of x. If r is equal to square root of x, r squared will be x. So your r squared will now only be x dx. I hope it's clear. So your r squared, your r is equal to square root of x, but you need it r squared, so r squared, you square this one and it will become x. So your volume is x dx. So getting the integral, volume is equal to pi. So the integral of x is x squared over 2. So we have to evaluate it from 0 to 4. Okay. So pi. So this becomes 4 squared over 2 minus 0 squared over 2. Now the volume would be pi. So this becomes 0. 4 squared is 16 divided by 2 is 8. Let's just put it here. 16 over 2. So your volume is 8 pi. 16 divided by 2 is 8. So this is your volume. This is the volume of this cup-shaped volume. Now we need to take the volume of this funnel-shaped one, the inner one, because we need to subtract it from this larger volume. Okay, the volume now, so this is volume 1, this is volume 2. So this is volume 1. Now for volume 2, again the area is, for area is pi r squared, where r is equal to the x squared over 8. So your volume would be, pi. So if your r is x squared over 8, your r squared will be squaring both numerator and denominator, x to the 4th over 64. So this is your r squared. We can now use this r squared to put in your formula for the volume. So the volume will be pi, evaluated from 0 to 4, x to the 4th over 64, that's your r squared, and then the x. Oh no, this is now the volume. So this is now your volume. So this is your thickness, this is your area, pi r squared. Now, so we can integrate this one, x to the 4th over, so it becomes volume 2 is, now in here we can take this outside because this is a constant. So this, you can rewrite it now outside, so pi over 64, we don't need to integrate that one. And then integrating this one, so x to the 4th, it becomes x to the 5th over 5. And then we evaluated it from 0 to 4. Now substituting 4, it becomes pi over 64. This becomes 4 to the 5th over 5 minus 0 to the 5th over 5. So this is your 4, this is your 0. Your volume would be pi over 64. So this becomes 0. What you have is 1024 over 5 So I will simplify it. We're running out of space. If you simplify this one, it becomes 16 pi over 5. This is your volume 2. Now, your volume is volume 1 minus volume 2. So your volume is actually volume 1, which is 8 pi minus 16 pi over 5. And if you subtract this one, what you have is 24 pi over 5 cubic units, or units cube.